Okay, so taking a look at our 6.4 material, which is special products with polynomials. Now this whole section, I think, is one where it's more of a shortcut section, as it were. If you see any of these things or recognize any of these patterns, you can jump directly to the final answer without having to do the previous process that we did in 6.3. You can still multiply everything out and expand it and everything for yourself, as we'll see with a couple examples. But these special properties are always going to have answers in a specific form. So our first ones that we're going to take a look at are the binomial squares patterns. This follows the pattern that if I have a binomial a plus b to the second power, my answer is always going to be the same as saying a squared, whatever our first term is squared, plus 2 times ab, whatever our first term is times our second term, plus our b value, or whatever our b term is, squared. Very similarly with the quantity a minus b squared, we're going to get almost the exact same thing, except we're going to have a subtraction sign in there. These two are also referred to as the square of a sum, which we have right here, and the square of a difference, which we have right here. So if you see an instance show up where I have a binomial raised to the second power, we can jump to this answer if we correctly identify our a and our b value. Similarly, if we have the difference of two things raised to the second power, we can correctly identify our a and our b value and jump to our final answer in this form here. I'll go through a couple examples of this farther down below. I do want to note that I think these two are some of the harder ones to memorize of these special products. And again, these special products are not ones that you are absolutely required to have memorized for multiplying polynomials together. I think it's nice to have them memorized, but again, I think these two are a little bit trickier to have the final answer nailed down for ourselves. If you're able to do that and keep track of that for yourself, fantastic. Then you can absolutely just jump from here's what I've been given at the start, jump to your answer. No work required, which I will be making a note of and keeping track of on the test if I were to give you something like this. Now the other one that we have, and this one is absolutely worth memorizing because this is very, very distinct and I think very, very quick and easy on the answers that we can kind of get. And it is a conjugate pair of binomials if we are multiplying those together. So our definition of this, it's a pair of binomials that have the same first term and last term, but one is a sum and the other is a difference. So most notably, in our general form, we could think of the conjugate pair of binomials as a plus b, and its conjugate pair is a minus b. Vice versa, if we're starting with a minus b, its conjugate pair is a plus b. So what happens when we actually multiply these conjugate pairs together? We get a very, very special product that shows up out of this, and this is one I would highly recommend you absolutely memorize for yourself. So if I have a plus b times a minus b, my result is always going to be a squared minus b squared. So identify what the a term is, identify what the b term is, and then square them, and then you just get to your final answer. And this is always, always, always going to be the case. We'll go through some examples down below where I'll show you guys what this actually ends up looking like. But this is absolutely a special product you want to have memorized. It can save you a lot of time with having to write things out. This is also an extraordinarily important one to have memorized going into Math 97 when we get into factoring. Very handy to have there. So we have this very special property of the multiplication of two conjugate pairs of binomials multiplying together here. Now I do want to give a warning with this because a lot of people think that, well, if there's a special property that gives a squared minus b squared, there has to be a property for a squared plus b squared, right? And it's not an unreasonable thought. However, there is no special property attached to this thing. We can and will sometimes get this as a final answer, an a squared plus b squared final answer that we're working with. However, there is no consistent property that always works for finding this to be the final answer. There's no special property attached to this. A lot of people think there is, and again, it's a very reasonable thought to have, but unfortunately there is no special property attached to it. So recognizing when we have the special product of conjugates, and recognizing when we have the square of a sum, or the square of a difference, is something that you can use as a shortcut to allow you to jump to an answer with minimal work shown, if you so choose. With both of these special pairs, or I shouldn't say special pairs, special products, types of special products, if and or when we have them on the homework, and if and or when we have them showing up on the test, you do not need to show your work if you recognize each of the a and b values that we're working with, and then rewrite the product into its result, either of these that we have here or the answer that we have right here. So I'm going to go through and show you guys what I mean by going through and using these properties on each of these examples that we have down below here. But these properties are the ones that we're going to be referencing as we go through these examples. So we'll jump us over to our Blackboard. Divide these lines up for ourselves so we know what we're working with. Okay. So our first example that we had, we were working with the quantity 2x squared plus 6y, and all of that is raised to the second power. Now here I have the special property of the square of a sum. I have a binomial 2x squared plus 6y being raised to the second power. So this is the square of a sum. Now, if we recognize that, we can correctly identify what is our a value and what is our b value. If we're going to do that and use the shortcut, I recommend writing it out for yourself. So our a value is 2x squared. It's this whole first term. What is our b value, including its sign? Well, it's just going to be 6y. Now, our special form tells us that if we correctly identify the square of a sum, which is what we have here, we can write our final answer as a squared plus 2ab plus b squared. Again, that just from the very top of our notes. So if I wanted to write that out for myself for our specific example that we have here, I would have a squared. So, whoops. That's my a value, plus 2a times b, a times b, plus b squared. The b value is 6y. I'm squaring it. And from here, now we simplify everything down and we can get to our final answer. So 2x squared to the second power, working with the numbers, 2 squared, it's going to give me 4. X squared to the second power, that's using our power rule from 6.2. That's going to give us x to the fourth power. Center term, we have three things multiplying together. 2x squared, and 6y. So I'm going to multiply the numbers together first. 2 times 2 gives me 4. 4 times 6 gives me 24. 24 for my numbers. I have an x squared, but no other x's, so the x squared is just going to stay there. I have a y, but no other y's, so y is just going to stay there. And then for my last term, I have 6y to the second power. 6 to the second power, 36. Y to the second power, y squared. And we have our final answer. Now, if you wanted to, and I think this is, again, just want to list this option for yourself. If you don't want to use the special property that we have here, which is fine, what you can do instead, we're going to rewrite our problem we started with. If you don't want to use that special property that we just went through, which is perfectly fine if you don't want to, then you also have the option of expanding and simplifying this binomial. You have the nuclear option with just about everything when it comes to exponents of expanding and then simplifying. So what that means is you could rewrite this to be in the form 2x squared plus 6y times 2x squared plus 6y. This 2 out front says that everything inside the parentheses, which is its base, is going to multiply by itself twice. So you could expand that out and actually write that base multiplied by itself twice. And then you would go through the process that we did in 6.3, and you would find that you would get to the exact same answer over here. So I will let you guys go through, and if you would like to use that alternative method where you expand and simplify, I will let you guys go through and do that by hand on your own if you would like to, but you should get to the exact same answer as we have here. So looking at our second example where we have the square of a difference, so we are starting with 3ab squared minus 5 all to the second power. So you can also think of this, because we have a's and b's in this particular problem, you can think of it as the first term and the second term by comparison to how we had our original equation written out on our notes. So I need to identify what is the first term, what is the second term. So instead of a and b, so we don't get the variables crossed over, you could say, what is the first term in this binomial? Well, it's going to be that 3ab squared. So the second term is going to be 5. So our answer told us, if we're using the shortcut, it's our first term squared. So 3ab squared, the second power, minus 2 times the first term times the second term, plus the second term squared. And now from here, I'm simplifying each of these parts down. Looking at our first part, I have the quantity 3ab squared to the second power. So I'm going to work with those individually. Numbers first. 3 to the second power is going to give me 9. A to the second power is going to give me a squared. B squared to the second power, so using our power rule, is going to give me b to the fourth. An exponent raised to a power Can multiply those things together. Working with our middle set of stuff, I have -2 times 3ab squared times 5. Work with the numbers first. -2 times 3 is going to give me -6. -6 times 5, -30. I don't have any other a's or b's in this middle part, so I'm just going to put the a and then b squared in there. And then for our last part, we have plus 5 to the second power. It's going to give me 25. I can't combine anything else together there. So I have my final answer. Okay. So again, if we're going through these and we're saying, I'm not entirely sure I want to use this shortcut method with multiplying these things together, that's perfectly fine. I'll be entirely honest with you guys, when I first learned about these quote-unquote shortcuts, the square of a sum or the square of a difference, I was not the biggest fan of using this process as well. So again, you do have the option, as like we did with the first problem, you can rewrite this into expanded forms, or the expanded form, and then multiply it together that way. There's nothing wrong with that. So write that out here, expanded for us. Whoops. The number is correct here. So we had that, so alternate method. Is saying, yeah, I'm not going to use the shortcuts, which is fine. Again, I'm not as particularly big fan of the quote-unquote shortcuts, the square of a sum and a square of a difference myself. And I'm going to instead expand this out as two binomials multiplying together. So write it out as 3ab squared minus 5 times 3ab squared minus 5. So now it's an 8.3 problem, or not 8.3, a 6.3 problem, my mistake there. And we can use the distributive property, and we will find that as we go through, we'll get to our same final answer. So this shortcut method with identifying the first term to the second term, and then automatically plugging those into our final answer, that is an optional method. You do not need to use it if you are not comfortable with it. However, if you are not comfortable with it, which is fine, and you are going to choose to write it out in expanded form and then multiply the binomials together that way, like we have over here on the right-hand side, make sure you are correctly identifying the base of the exponent out here, and make sure, above all else, you actually write that out in expanded form. I cannot tell you guys how many times I see people just say, well, based on this, I'm just going to square this minus just going to square this. That's 100% incorrect. You absolutely must expand that thing out into two binomials multiplied together, and then multiply those things together in that form. So some of the other pitfalls I'm going to show you guys before we move on to the conjugates, because I think the conjugates are a bit easier to wrap our minds around. So here's your warning. If you have something like x plus 2 to the second power, that is not equal to saying it's x squared plus 4. Wrong. These things are not equal to one another. If you have something like, let's say, 3y minus 5 to the second power, that thing is not equal to saying, oh, it's just 9y squared minus 25. A lot of people make this mistake with thinking, I just need to square the first term, I just need to square the last thing, and then just keep the sign in the middle, and I'm perfectly fine. No, you cannot. If you are going to work with it this way, you either have the option of using the shortcut that's on the notes, or expand those binomials and then multiply them together with our 6.3 process. But you cannot just distribute the exponent through willy-nilly and say, okay, I'm just going to square that part, I'm just going to square that part, and then done. Cannot do that. You cannot do that with binomials, trinomials, anything like that. Okay, so that's just warning I want to put out there. Now we're going to get to our multiplication with conjugates, because these are really, really nice. Really, really good terms, or really good shortcuts to have memorized. So our third example from that section that we were working with, we have the quantity 9x cubed minus 4y squared times 9x cubed plus 4y squared. And again, this is a special instance. These two things, two binomials, are the exact same, except one is subtraction, one is addition. That's your giveaway. These two things are conjugates, and they're multiplying together. So the way that we do this, again, the shortcut is saying, what is the first term in both of these polynomials? It's going to be 9x cubed. So that first term, we're going to square it. Minus, if we take that second term, 4y squared, and we square it. This is the general form for our final answer. I'm going to show you guys what happens if we actually multiply these things out, but this is where then this trick is really, really handy with the time that it saves us. So our first part, 9x cubed to the second power. Simplifying that down, 9 squared, 81. X cubed to the second power, x to the sixth. Minus 4 squared, so give me 16. And then y squared to the second power, and give me y to the fourth. So we have our final answer there. So this is the shortcut to get to our final answer if we see a conjugate pair of binomials show up. And again, the dead giveaway is that the first and second terms are the exact same, but the sign of one is negative, sign of one is positive. The order doesn't matter on that part. And I want to show you guys why this is such a great method and good shortcut to have memorized for yourself. So if we went through this with the alternative method, meaning we actually distributed everything through, so you went with our 6.3 methodology. The first term from the first polynomial distribute through to every term in the second polynomial. So I'm doing 6.3 material. So just distributing that 9x cubed to every term in the second polynomial. And then distributing the second term from the first polynomial through to every term in the second polynomial. Oops, there we go. Oops. Have that written out correctly. Yeah. So I've just done the distributive property. Again, 6.3 material here. Multiply everything together, so we have it showing up here. So I'm getting 9x cubed times 9x cubed. 9 times 9 is 81. X cubed times x cubed is x to the 6th. Second part, 4y squared times 9x cubed. Numbers first. 4 times 9 is going to give me a positive 36. Y squared and x cubed, I don't have anything else shown up in there, so I just list the variables. List them in alphabetical order for yourself. Then we have 9x cubed minus 4y squared. Numbers first, positive times a negative is a negative 36. X cubed y squared. Now with our last term, 4y squared minus 4 times negative 4y squared, I should say. Numbers first, positive times a negative is a negative. 4 times 4 is 16. Y squared times y squared is y to the 4th. And now I'm combining like terms where I can. I have an x cubed y squared, x cubed y squared. Positive 36 minus 36, well, those are just going to cancel. I'm left over with 81x to the 6th minus 16y to the 4th. And we find the exact same answer. So this is the main reason why of the 3 new kind of special products that we have, I would highly recommend that you memorize this conjugate pair for yourself. The first 2 examples that we did, the square of a sum, the square of a difference, if you want to memorize it for yourself, you can. It's handy, but I think it's way too much to memorize for its real usefulness. Like it's useful, but I think it's a little too much to memorize, and it demands another level of organization as you go through it compared to this one. Both are perfectly viable, so it's your choice if you want to use them or not. And it's also your choice on whether you want to use these methods or use these 6.3 methods that we have, where you actually write these things out in expanded form and then multiply them together. You'll get the same answer either way. These are just optional shortcuts that you can use. But again, of all of these, I think this conjugate pair one, this is absolutely one that you want to have nailed down for yourself. This can save you a lot of time. It's pretty straightforward compared to the other 2, I think, by comparison. A little bit easier to remember. Okay, so I am looking at our time. I do want to have some time for questions at the end here. So I'm going to end our recording here. And I'll take any questions that you guys have shortly after.